Oh, and the video wasn't on. So now the video has started. So here we have the question, x squared minus 8x equals 33. How many ways do you know of solving this question? Okay, now I see in the comments, someone says 2 ways, someone says 4 ways, and unless I wrote the question out wrong, I think the answer is going to be an integer or 2 integers. So one way of doing this question would be, as they say, guess and check. Literally, if you put a really big number in for x, like if you put 100 in for x, for instance, well, the 100 squared is going to be way bigger than 80 times 100, and it's not going to get to be 33. But if you put a number too small in, like 1, you're going to get something negative. So it's somewhere between 1 and 100, and maybe through some sort of trial and error, you come up with 11 as the positive answer that makes it true. Now there's also a negative answer. -3, people have written, -3 squared is 9, minus 8 times -3, so it's 9 plus 24 is 33, works also. I'm most interested in the x equals 11 answer, because this question, which dates back all the way to Babylonian days, at that time, the idea that there was no concept of negative numbers. And I see here completing the square, factoring. So the finding the x. So I see 4 methods. Nina wrote factoring, quadratic formula, completing the square, and factoring, or in graphing. And let's look at those first 3 ways. Almost every approach starts with moving everything over to the left-hand side. Now, if this does factor, we would need 2 numbers whose product is -33 and whose sum is -8, and that seems to be -11 and 3. So if it does factor, we're able to answer the question that way. But that's not how the Babylonians would do this question. But I just want to do a little survey of different ways. One of the best ways to answer a question like this is to use the so-called completing the square method. And just to give you a little background on that, in algebraic identity, that's very useful, is that a plus b squared is a squared plus 2ab plus b squared. And I mentioned yesterday, there is a pretty nice picture that illustrates that. I like that picture. Now, if it's not a plus b, but it's like x plus 5, then you would get x squared plus 2ax, which in this case, or I should say, the a and the b are x and 5, so we'd end up with 10x. And if I had x plus, let's say 3 squared, it would be x squared plus 6x plus 9. The 9 is just the 3 squared, but the 6 is double 3. Things like this are known as perfect square trinomials. Which means that you can factor them into something times itself. So if you ever saw, and the way to recognize a perfect square trinomial is that the constant, in this case the plus 25, is equal to half the coefficient of the x squared. So if you ever notice that, it's a perfect square trinomial. And if I showed you the first two terms of a perfect square trinomial and asked you what should go in the box, what would you say? So if I say this is equal to something squared, what would go in the first box? What would go in the second box? You can type some stuff into the comments. Okay, and this is correct. 36 goes into the first box because it's equal to half of 12, and then square that. And 6 goes in the second box because what it factors into half of 12, it was going to go over here. So doing this initial question, this x squared minus 8x equals 33. If you're going to use the completing the square method, you actually don't move the 33 over to the other side as you would with the factoring approach. Instead, you would say, okay, what needs to go? What would need to go after the negative 8x so that the left side was a perfect square? You could type that in. And that's right, it is 16. But when you add 16 to the left side, you have to add it to the right side also, because it wouldn't be equal otherwise. Now that the left side has been made into a perfect square, we can actually rewrite it as x minus 4 squared. And the right side becomes 49, which is really convenient because when I take the square root of both sides, and we're just going to do the positive answer, even though I know negative 7 squared is also 49. But because the Babylonians wouldn't care about the negative answer, we're not going to worry about it either. And then if you add 4 to both sides, you get 11. This is all just a little summary of where sort of our modern approach, because I want to compare it to the Babylonian approach. And then, of course, there's the infamous quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. So that one just requires just popping everything into the formula. (33 times 4 is 132. 64 plus 132 is 196. Something go wrong there? 14 times 14, sorry. So it becomes 8 plus 14 over 2, which is 11. I could also get a negative answer, but I'm going to ignore the negative answers. I'm going to do a quadratic formula that doesn't have a minus in it. And I did see other approaches, graphing and things like that. Well, the Babylonians were interested in a question like this. And good news for you today, and for tomorrow also, we're not going to do base 60 anymore. we studied base 60, we got a little exposure to it, but the rest of the topics, we're going to just do all the algorithms with base 10 numbers because it's confusing enough in base 10. No need to have base 60 involved in it also. Now math, we think of math as having been invented for practical purposes. Counting livestock, trading goods. In Egypt, they did a lot of stuff with bread and beer and how to trade them and how much this beer is worth compared to this other beer. So that a lot of math is very practical. But what's notable about this equation that the Babylonians solved and worked on is it's really not a practical question. X squared minus 8x equals 33. I mean, they turned it into a word problem. They might say, I have a square and the area of the square minus 8 times this, they would call it the square side, is 33. And they wanted to know what are the dimensions of the square, but that's not practical in the sense that like somebody needed that for their job. It's almost recreational math. Just it's a thing we can do. Now, yes, nowadays quadratic equations might have some applications in economics and physics, but back in 1600 BC, this question did not have any practical application. It was just a question that they could learn how to do. So it's a very early example of math for like the sake of math, just because they can do it. It didn't help anybody's life to be able to answer these questions. And I find that interesting that math was recreational even, almost 4,000 years ago. Well, how they solve that question is going to be coming over the next hour. But first I want to remind you, of questions like this. Systems of equations. By this, I mean, if I told you, hey, I'm thinking of 2 numbers and they add up to 10. Well, it's not possible to know what the 2 numbers are. There's so many combinations. But if I give you a second hint and I say the difference of that number, of those 2 numbers, is 4. Now I have a so-called system of equations. And you could do this various ways, even by just playing around with the numbers in your head. What's the value of x and y that make these equations both true at the same time? Good. Now I see a lot of 7s and 3s. What's the official? There's several ways. What's one official method of, like in algebra, 8th grade algebra? I start teaching this, I think, in 7th grade, 8th grade nowadays. So one way is substitution. Substitution is where you would take y is equal to 10 minus x, and then you would substitute x minus parentheses 10 minus x equals 4, x minus 10 plus x equals 4, 2x minus 10 equals 4, 2x equals 14, x equals 7. That's one way. And then I see also a few people mention the elimination method. And that's going to be our preferred approach. So let me go back to x plus y equals 10. And this is all being saved, and I now am posting these things faster. Elimination is when I add the 2 equations together, and I get kind of fortunate that the y's cancel out, as they say. We get 14. And then you can take either of these equations. Once you get x established as 3, you could then just say, okay, so if x is 7, sorry, 7 plus something has to equal 10, and the other thing has to be 3. Now, imagine the question, the given wasn't x plus y, but it was x plus y over 2 equals 5, and x minus y over 2 equals 2. Now, one thing you might say is, oh, I'll double them and just do it like the last problem. But there'd even be a better way to complete this question, even faster. And what would that be? Well, yes, if you cross multiply, you'll turn it into the x plus y equals 10, x minus y equals 4. But there's going to be something even better than that. I'm talking specifically for this question, where the things that you're given are x plus y over 2 and x minus. Now, you might say, well, this is so easy. I'll just, do x plus y equals 10. Yeah, multiplying both sides by 2 would turn it into the last question, but we don't even have to do that. Yes, if you were to add these two equations, you would get 7 on the right, and x plus y over 2 plus x minus y over 2 is just 2x over 2, which is just x, and the question is finished. So in this special situation where we happen to know x plus y over 2 and x minus y over 2, and while we're at it, if you subtract the two equations instead, you would get 2y over 2 equals 3. In other words, y equals 3. Because when you subtract, let me just kind of go like this, x plus y over 2 minus x minus y over 2. When you subtract, you have to be very careful about this negative sign out here. If I wanted to get rid of these parentheses, it would be x plus y minus x, and then this minus would become a plus y because you kind of distribute that negative through. And then the x's cancel out. So if we're lucky enough to somehow be told what x plus y over 2 is and x minus y over 2 is, that's ideal. Then I could just add them, and I have x, and subtract them, and I have y. Okay, now let's see as we start working towards, and there are 6 questions that we're going to be doing. Today's lesson centers around 6 categories of question. Well, 3 categories, but 6 types because some have a minus and some have a plus in them. Here is an important question. So x plus y is 14. So they're telling us the sum of the two numbers. But instead of telling us the difference, which is really good to have, instead they tell us the product. And this system of equations comes up in Babylonian times. Sometimes they would say, like the sum of two numbers is 14, the product is 40. Or they would talk about a rectangle and say the area is 40 and the perimeter is 28, which would make, if this is x and this y, that's another way if you wanted to make it into like a word problem. The length and width, find the length and width of the rectangle whose perimeter is 28 and whose area is 40. Now this question we can't do by elimination. We can't add these two equations together. What's the modern approach to this question? You could type it in. Babylonians aren't going to do it by the modern approach, but I like to compare what we do now to what we did then. So I'm just curious, what is the official way, like the modern approach to this system of equations? Okay, Substitution, I see. So what would I substitute? Which one? Good. If we take the top equation and we rewrite it as y equals 14 minus x, I can then replace the y with 14 minus x and get 14x minus x squared equals 40, which turns into x squared minus 14x plus 40 equals 0. So it turns into this so-called quadratic equation. But this quadratic equation, which can be solved by factoring, what do we need to do to factor this thing? Because here we are, I'm doing it by the modern approach, and here I am at the factoring step. What are the two answers, by the way, like for x? Or what are x and y? You could even look just at the original equation. What two numbers have a sum of 14 and a product of 40? Oh, someone asked about the plus sign. So I moved everything over to the right-hand side. So it was okay to have x squared. I moved the x squared to the right and the 14x over, so it was okay to have the minus there. But yes, the answers are 10 and 4, because this thing factors to x minus 4, x minus 10. But the kind of funny thing about this method is that in order to factor it, you had to ask yourself, okay, factoring is when I find two numbers whose sum is 14 and whose product is 40, which is exactly what the original question was asking anyway. In other words, if you didn't know how to, if you had no method for answering the original, if somebody took this original question and said, oh, it's 10 and 4, and they were on like an algebra class, like a 8th grade or 9th grade algebra class, they wouldn't get any credit on like the algebra regions or something. If they just said, oh, I guess and check, 10 and 4, 10 and 4. Those are the two numbers that add to 14 and multiply to give me 40. Yet if somebody went through this whole process and then they factored it by thinking to themselves what two numbers have a sum of 14 and a product of 40, that person would get full credit. So in that way, the quadratic formula is like a little better than factoring. At least it's like a step-by-step formula that doesn't require basically redoing the original question. Anyway, the Babylonians didn't do it this way. So now I'm going to come back to this question. And now I'm getting finally to the actual questions of the day. There are 6 of them, and here is the first one. There's 3 types of questions and 2 variations on each type. So this question about where the sum and product are given, we find these Babylonian tablets that say, it's written very cryptically. It's written just like sentences, what to do. Step 1, take half the sum and get 7. Take that 7 and square it. Take that 49 that you just got and subtract the product, which is given. Take that 9 that you just got and take the square root of it. Add the first number, which was the 7, to the 3. And that's going to be one of your answers. And subtract 7 minus 3. And that's going to be your other answer. So this is a 1, 2, 3, 4, 5, 6 step process. We'll analyze it in a minute, but let's keep that up on the screen. Let's keep that up on the screen and have you do a practice question like this. So all I'm going to do is change the numbers. I'll even make it small. Let me make these numbers smaller just to. So x plus y equals 12. And xy equals 35. Okay, would you go through without yet knowing? Yes, this process is specifically when the given information is the sum of the two numbers and the product of the two numbers. Would you go through and do the 6-step process? Just follow these same 6 steps. This is always dividing by 2. This is always squaring. This one's always subtracting. And take a minute to go through the Babylonian process. And why don't you go ahead and you could type into the comments, what are the sort of the 6 numbers that pop up? You could put like a comma between them. Like this one, I'd write 7, 49, comma. Okay, I'm going to put myself on mute so I don't disturb you. Okay, I see there Stephen E. has the numbers 636, 1175, and that is correct. 12 over 2 is 6. 6 squared is 36. 36 minus 35 is 1. Square root of 1 is 1. And then you just add 6 plus 1 and do 6 minus 1. And on the Delta Math tonight, they ask you questions like this, and whether you get it right or wrong, it will show you what these, it will show you this collection of numbers. So at least you'll see like what, if you did it wrong, what the sequence of numbers should have been. Now, why this process works will give us an insight of what to do when there's not a plus there, when there's a minus instead. So I'm going to erase this one on the right. And this whole video will be up for you. Okay, now the reason this works, this 7 is x plus y over 2. Because that's what we did on the first step. And remember before I said it's really good if you know x plus y over 2? But it's also nice if you know what x minus y over 2. Well, for reasons, and by the way, we know the answer is 10 and 3. Did I say 10? Not 10 and 3. 10 and 4, sorry. So this 7 is x plus y over 2. Somehow this 3, after we take the square root of 9, that 3 will always end up being, and I haven't told you why yet, but I'm just telling you now just to give a feel for why this works. That 3 will be x minus y over 2. Now, why that is, I haven't told you yet, but I just am telling you now that these cryptic steps of squaring and subtracting and taking the square root somehow get us from x plus y over 2, which I kind of start with, to x minus y over 2. And then when I add those two things together, they become x, which is 10. And when I subtract them, they become y, which is 4. So that's the big picture of what's happening. But then the mysterious question is, why? How does this sequence of squaring, subtracting, square rooting get me from what I had, x plus y over 2, to what I eventually ended up at here, which is x minus y over 2? Well, that is all because of the major Babylonian identity I mentioned yesterday, x plus y squared minus, let me write it this way, x plus y squared minus 4xy is equal to x minus y squared. That's the big Babylonian fact. If there's one thing that they did, it's they recognize this is true always. Now, if you take this and divide everything by 4, it turns into the identity x plus y over 2 squared minus xy equals x minus y over 2 squared. What I did here is, since this is over 4, if I put everything inside the parentheses and put a 2 there, it's equivalent. Well, that's an identity also. So if you have x plus y over 2 squared minus xy, well, that's exactly what happens in this algorithm. You see, this here is x minus y over 2 squared. And this 9 is x minus y over 2 squared minus xy, which is exactly what this is, which means it's the same thing as x minus y over 2 squared. And that's why when I take the square root of it, I'm just going to say equals x minus y over 2 squared. That's what the 9 is. On the one hand, it's x plus y over 2 squared minus xy, but because of this identity, it can be replaced with x minus y over 2 squared, so that when I take the square root of it, I end up with just x minus y over 2, which can get put together with the x plus y over 2. That's the gist of why this works. Again, as long as you can do the 6-step process, I'm happy, but I am trying to show you why it works. But so some people, maybe all these x's and y's are intimidating for you. I'm happy if you know the 6-step process for now. Now look at this question. This is question 2. There's only 6 today. Question 2 is, what would happen if instead of the sum and the product, I had the difference in the product? Well, check this out. It's almost the same process. We still start by dividing this number by 2, and we square it. But this time, instead of subtracting xy, we're going to add xy. That's the only difference in the process. Now when I take the square root of that, I get 7. And I do 7 plus 4 and 7 minus 4. And just in this case, it matters that like x is the bigger one. So that's how we do it when there's a minus up here instead of a plus. It's the same process with 2 little adjustments. One is that this is going to be a plus here instead of a minus. And secondly, because x minus y and y minus x are not the same thing, we have to just be careful into which one we call x and which one we call y. And this works because if I take this identity here and I just add the xy to both sides, it would tell us that x minus y squared over 2 plus xy is equal to x plus y squared over 2. Back to here for a second. Oh. Totally lost what page I was on. These are not in the order that I would have expected. There it is. So this 4, just for analysis, is x minus y over 2. And after you take the square root, it's going to be x plus y over 2. And that's because this 16 plus 33 is x minus y over 2 squared plus xy. So that thing got converted into x plus y over 2 squared, so that when I take the square root, I end up with that. Again, if you can do, like on the homework, if I ask you to solve this and you could produce these 6 numbers, 1, 2, 3, 4, in this order, I'm perfectly happy with that. That's what you're sort of being graded on. But you might be, some people are, really maybe have more of a background in the algebra, and for them, they want to understand like the ins and outs of this. So there's something for everybody. But on like a test, now in the math major class, for example, I give them other configurations that they have to like figure out based on really understanding the x's and the y's. But for this section, I want you to just know what the algorithm is, maybe have a general idea of why it works. But even if you just know how to do the steps, that's still good. Okay, we're about 40 minutes in, I think. Oh, someone's trying to get into the class. There's 4 more questions to do. Okay, this next question is going to look familiar. The first question I showed you, x squared minus 8x equals 33. Now this question is officially a quadratic equation. Those last 2 were what I would call systems of equations that turn into quadratic equations if you choose to turn them into them with substitution. But this one doesn't have a y value. It just has an x. There's no y in here. Anyone who's an algebra teacher? Is there anyone who teaches, who's taught 8th grade algebra, like solving, factoring, quadratic? You could click a little yes in this box. I see people with their hands up there. There's a little icon. It's funny, mine has a yes, no, but not a hand. Maybe as the I don't get to raise my own hand. Click on either a hand raise on your participants list or a yes, no. If you've taught this, if you've taught quadratic equations like this. Okay, good. Well, for those people, what mistake at this point makes a Algebra 1 teacher like throw the paper? What's the worst thing someone could do at this point, even though it's not mathematically an incorrect thing to do, but it just doesn't seem to go anywhere? What is it that people might be tempted to do right here? And I see a few people said factor out the x. And that makes math teachers crazy because everyone knows that either you're going to complete the square by adding 16 to both sides, or you're going to move everything over to one side and make it equal 0. Those are your two options. There is no third option. But let me do the unthinkable. Because the Babylonian approach is essentially to factor out the x. Now, it seems like a dead end. And when you teach algebra and students want to do this, you say, great, you did it, but now what? Nothing to do from here. You can't, it's not like when it says equals 0, and you could say, oh, so x equals 0 or x minus 8 equals 0. We're at a point here where it's like, now what? Seems like we're stuck, like dead end. But it's actually not a dead end because I'm going to temporarily replace this x minus 8 with a y. Because here I have two things that multiply to give me 33, just like x times y equals 33. But those two things, x and x minus 8, x is bigger than x minus 8 by 8. So it's x minus y is equal to 8. These two things that got multiplied together, their product is 33. But the other fact about them is because this is x and this is x minus 8, x is 8 bigger than x minus 8. So x minus y equals 8. I suppose you may not like, a lot of people like the y, but some people might like this. I've never actually thought of doing this before. I don't like this, but I'm going to show you that. Maybe if I didn't put the y in, those would be the two facts. Like the product of these two things is 33, but the difference between them is 8. I'm going to cross that out. I don't like that. But look what I have now. I have the scenario I just taught you, where you take the 8 and divide by 2. You square it. You add it to the 33. We add it because when there's a minus here, we add it. We take the square root of 49 equals 7. And the x is the bigger one. That's bigger. Bigger than x minus 8. Smaller. So I could just do 7 plus 4 equals 11. I don't need to do 7 minus 4. And that's how we solve. That question started off as x squared minus 8x equals 33. Let me put up on the screen and then I'm going to leave this up here for now, but would you now try to use this process to do x squared minus 12x equals 28? So I'm going to have you work now on this question. I'll leave the other one up on the screen. Try to model it. Let me erase that stuff and the now what dead end stuff there. Okay, so would you go ahead and do this process? And you could type into the comments. It would be great if you just typed in what these 5 numbers are. That way I'll know you did the process. In other words, this 4, 16, 49, 7, 11. If you could type whatever those 5 numbers end up becoming for this equation, that would show me that, that you got it. Yes, for homework, it's just going to be the positive values. This process is only going to produce positive values anyway. Oh, I see. You're thinking if I did, no, 7 minus 4. I see. We're only going to do the positive values. Or the positive value. There'll just be one answer. Okay, work on this. Type in the 5 numbers that come up. You could put that 12 as the first step, but really the first step is the 6. So that last comment, you need one more number because that 12 isn't really one of the 5 numbers. Okay, I see a lot of people with the first 4 numbers right, but some people make a little mistake near the end, but still really good in general. Answer is 14. And here are the official steps. X times x minus 12 equals 28. I like to call it xy equals 28. That thing. If you want to write on the side, x minus 12 equals y. And x minus y is 12. So the steps are 12 over 2 is 6. 6 squared is 36. 36 plus 28 is 64. Square root of 64 is 8. And it's 8 plus 6 that matters. And the 8 minus 6 actually doesn't matter. The 8 minus 6 is x minus 12, but there was no, the question is, what's the value of x? So that other answer doesn't matter for this one. It's just the 14. You could do both. You could do the 14 and the 2, but then mark 14 as x and 2 as x minus 12. Okay, so that is the 3rd question of the day. The 4th question, which is really related to the 3rd question, is what happens if there's a plus x squared plus 10x equals 56. Well, it's not so different, but there is one little difference that's coming. So when I factor out the x, I'm going to have a plus here also. xy equals 56 because I'm going to think of this x plus 10 as y. Okay, but here is where something changes a bit. Anyone want to type in what they suspect the other equation to be? It was x before it was x minus 12 equals, or sorry, let me just look for a second. Before it was x minus y equals 12. How does that change when there's a plus here? Interesting. So I've got, see, there's a lot of different answers so far. I see an x plus y equals 10, which is reasonable answer. I see x minus y equals negative 10. I see another x minus y equals negative 10. I see x plus y equals negative 10, and another x plus y equals 10. So I see about 4 different answers. Which one is it? Hold on a sec. Maybe I could do it as a poll. I haven't utilized these polls, but they're pretty neat. No, not that. Edit. I used to know how to make a poll. I've done it before, but it doesn't really let me edit it. Edit. Oh, here we go. Sorry. There's a lot of windows up on my screen. Okay, so we see x plus y equals 10. We see x plus y equals negative 10. We saw, I'll write in some more stuff. X minus y equals 10. Y minus x equals 10. Well, there's 4 choices. Sorry this took so long, but I'll know how to do this better for next time. Anyone want to vote? Which one is? I wrote is. Wow, from my end, it is almost evenly spaced between the 4 choices. Right now, it's like 1/4 for each choice. 9 out of 16 people voted. Everyone's got to vote. Don't worry. You could randomly guess it because that will cause us to still have evenly spaced between the 4 things. I worry if only 9 out of 16 people voted. Now it's up to 11. Maybe the other 4 people are not at their screens right now. Okay, well, 1 minute and 15 in, it was 17% voted for x plus y equals 10, 17% voted for x plus y equals negative 10, 42% voted for x minus y equals 10, and 25% voted for y minus x equals 10. Oh, look at that. I can share results. That's neat. Oh, does that mean I don't have the iPad showing still? Where is everybody? In the comments type, can you see the iPad screen again? Okay. Well, the most popular answer was actually not the correct answer, because the correct answer is y minus x equals 10, because this x plus 10 is 10 bigger than x. So the y is the bigger one. How much bigger? 10 bigger. So it's still going to be a minus there. It's always going to be a minus there. It's going to be y minus x instead of x minus y. The x plus y equals 10 was a good thought because, well, there's a plus there, so maybe there's a plus. But these things are still this thing and this thing are still 10 apart from each other. So it's got to be something minus something equals 10. But the y is bigger than the x in this case. So the way we complete the question is 10 over 2 is 5. 5 squared is 25. 25 plus 56 is 81. Square root of 81 is 9. And I have to do 9 plus 5 and 9 minus 5. I'm only going to do 9 minus 5 because the x is the smaller one. The x plus 10 is the bigger one. So it's only necessary to do the minus. And I guess that's a difference. To get the answer at the end, you do this minus that, as opposed to in the last situation, I would have done this plus that. That's because x plus 10 is bigger than x, so y is bigger than x. X is the smaller one, the one you get by subtracting. If you really wanted to do 9 plus 5 equals 14, that would be what x plus 10 is. I suppose you could do either of them and just solve for x. Okay, we've done it. We've done 4 of the 6 types. And if, in theory, this could be enough for one day. With the math majors, we did like 3 more types. But I'm going to do one more type because I want to go just for one more like sophisticated thing. So here it comes. Hold on a second. So let's call this the 4th one. Okay, so the issue here is that 5. That 5 is annoying. And if anyone's taught Algebra 1, you might go right to the quadratic formula because it's really hard to like factor when there's a 5. It's just annoying. Now, there is a very clever way to get rid of that 5, but it's not what you would expect. What would you expect the way to get rid of the 5 is? You could type that into the comments. The most logical way to get rid of the 5, even though that's not what they're going to do. There still is a most logical thing. Yes, dividing everything by 5 would get rid of the 5, but it would introduce fractions, and also in the Babylonian times, dividing by 5 might be easy enough, but dividing by 7 or something isn't really going to be possible for them because 7 doesn't go into 60 evenly, and it would cause a repeating decimal, which would be a real complication for them. They don't divide by 5. Instead, what they do is multiply. Oops, you're going to see some scribble come up on the screen as this lags. Instead, the first step is going to be to multiply by 5. You might think that's crazy. Why would I want to make the numbers bigger? How could it possibly be better to have a 25 there than a 5? 5 was hard enough. Now I'm making it bigger. One of the comments did say multiply. One of the comments said times the entire problem by 5, which was right. Okay, well, that's not getting rid of the 5. That's making the 5 into something bigger. But here comes the clever trick. Because I multiplied by 5, this number will definitely be a perfect square. So I can write this as 5x in parentheses squared. And while I'm at it, I'm going to take this 30x and write it as 5x times 6. I want these two things to match. Also worth noting that this 6 will always end up becoming the same number as was originally in front of the x. Now look, this is looking like, I'm going to call this, if you don't mind, just I hate to introduce more variables, I'm going to say that u equals 5x. Some people like the abstraction of replacing. I'm just calling it u for now because now it looks more like what we've been doing. Check it out. It is the last type, u plus 6. Now, I'm not going to, if you want to replace that u plus 6 with a y, you can. In fact, why don't I do that? See how I called it y minus u because the u plus 6 was bigger than the u? And that leads me to this 5-step process. Half of 6 is 3. 3 times 3 squared is 9. 9 plus 3, 15 is 324. Square root of 324 is 18. And we want to know what u is. U is the smaller one. So I'll do 18 minus 3 equals 15. Well, that's u. But remember, u is 5x. So 5x equals 15. And x equals 3, which is the answer to this question. Now, I know this is kind of a mouthful. Honestly, if you start feeling comfortable with this, it wouldn't be so bad to jump straight from here to here. You know, once you feel comfortable enough with the idea that it's related to like the last question, but I wanted to show all the steps. Why does that say 4? That should say 5 because this should be the 5th type of question. We did sum and product, difference in product, x squared plus something x equals something, x squared minus something x equals something, and then finally this one. Let me leave this on the screen and have you do the final question of the day, and you can talk about it. You can, maybe I should put you into a chat room. Hold on a second. But let me write down the question first. Oh, if I put you into chat rooms, it will, you won't see this screen. But let me write down the question at least. The question is 9x squared minus 20x equals 301. I'm going to put you into groups. How many people? We have 15 people. I'll put you into groups of 5 to discuss about this. I know this last question was pretty hairy. If you know how to do the first 4, that's the main thing that I'm interested in. But there are people at higher levels and different levels, and I do want to show you this, wanted to show you this really clever Babylonian trick to deal with that coefficient in front of the x. Okay, you are going into groups of 5. I'll put you in there for about 10 minutes and then come back, and then we'll be done. Let me pause my recording. Okay, everybody, so here's the answer. And you wouldn't need to write every single one of these things down. If you feel that you could like jump, if you feel that once you get to this point here, if you feel you could jump to here, I mean, I guess that would be sort of the minimal work. I mean, I do kind of like this stuff. But I suppose if you really understand what all the steps are and you feel having this green thing is unnecessary because it's so obvious to you, it's okay. That green thing would include those guys. Anyway, I like having all these steps. Your homework tonight is I think it's a delta math where you do like 2 questions of each type. So 2 where it's like the sum and the product, 2 where it's the difference in the product, 2 where it's x squared plus something x equals something, 2 where it's x squared minus something x equals something, and 2 where there's a number in front of the x squared. Oh, I see there might be somebody on a chat. Let's see, chat. Oh, yeah, okay. So yeah, there's some people like had a small step where it's a little confusing, you know, should I do, some people got 43, you know, should I do 53 plus 10 or 50? The reason I did 53 plus 10 instead of 53 minus 10 is because the u was the bigger thing. The u minus 20 was the smaller thing. So because the u is the bigger thing, bigger than u minus 20, basically if there's a minus here, you'll end up doing a plus here. And that's why it was 63, not 43. Okay, I'm going to call it a day, but I'm going to stick around for a few minutes.
I have a question, Professor.
Yes, yes.
So tomorrow we're not meeting, right?
Tomorrow.
Or are we meeting?
So I'm going to try to have us meet tomorrow.
Okay.
There's a chance we won't meet tomorrow because I'm going to be out at a doctor's appointment. But my goal is to actually have us, you know, when I say have a meeting, even, you know, maybe you were, if you're not able to come to